Welcome everyone. Today, we are breaking down the absolute foundation of computer networking, the OSI 7-layer model. Whenever you send a message or click a link, your data embarks on a fascinating 7-stage journey across physical wires, routers, and protocols. By the end of this video, you will master every layer with crystal clarity. Back in the 1970s and early 80s, computer networking was proprietary. IBM systems used SNA, DEC used DECnet, and equipment from different vendors could not talk to each other. To solve this vendor lock-in nightmare, ISO introduced standard 7498-1 in 1984, the OSI reference model, establishing open vendor-neutral standards worldwide. Layer 7 is the application layer, the layer closest to the end user. Important distinction: software like Google Chrome is not Layer 7 itself, rather, the network protocols Chrome uses, like HTTP and HTTPS, reside here. DN is for name resolution, SMTP for emails, and SSH for secure terminals all operate at Layer 7. Layer 6 is the network's translator. It ensures that data sent from the application layer of one system can be read by the application layer of another. Its three primary duties are syntax translation, like UTF-8, JSON, JPEG, cryptographic encryption and decryption, TLS SSL, and data compression, zip, broadly. Layer 5 establishes, manages, and terminates dialogues between local and remote applications. It handles session synchronization via checkpoints. For instance, if you are downloading a 2 GB file and the connection drops at 1.5 GB, session layer checkpoints allow the transfer to resume right where it left off, avoiding restarting from zero. Layer 4 is known as the heart of the OSI model. It provides host-to-host, process-to-process data delivery. It segments large payloads, assigns port numbers, and manages flow control. Here we have TCP, connection-oriented, reliable with a three-way handshake, and UDP, connectionless, ultra-fast, ideal for live video streaming and gaming. Layer 3 is all about routing, determining the optimal physical path for data across interconnected networks globally. It encapsulates segments into packets by prepending source and destination IP addresses. Routers operate here, evaluating routing tables via protocols like OSPF and BGP to navigate packets through internet hops. Layer 2 handles node-to-node data transfer across the same local physical network segment. It packages packets into frames, attaching 48-bit hardware MAC addresses. Crucially, it appends a trailer containing a cyclic redundancy check, CRC-FCS, to detect if electrical noise corrupted any bits during transmission. Layer 1 is the physical foundation. There are no software headers or logical addresses here, only raw binary 0s and 1s. It defines how bits convert into electrical voltages over Cat6 copper cables, laser light pulses through fiber optics, or radio frequency waves over Wi-Fi. Now observe the complete journey. When you send a message, it moves top-down. Each layer wraps the payload with its specialized header. This process is encapsulation. Bits travel across the physical wire. At the receiver, each layer strips of its header, decapsulation, delivering the original pristine message to the destination app. Now observe the complete journey. When you send a message, it moves top-down. In the real world, the modern internet runs on the TCP/IP protocol suite. TCP/IP condensed OSI's top three layers, application, presentation, and session, into a single unified application layer. It also combined the bottom two layers, data link and physical, into the network access layer, streamlining 7 theoretical layers into 4 practical layers. Never mix up the layer sequence in your exams. For top-down, layer 7 down to 1, remember, all people seem to need data processing, APSTNDP. For bottom-up, layer 1 up to 7, use the classic, please do not throw sausage pizza away, PDNTSPA. When network issues strike, professional engineers diagnose systematically from the bottom up. 1 is the cable plugged in. L1, 2. Is there a link light on the switch? L2, 3. Can you ping the default gateway? L3, 4. Is the port open via telnet curl? L4, 5. Does DNS resolve and the web app load? L7. If you found this video helpful, hit like, subscribe, and share it with fellow engineers.